This
inventory,
conference will now be recorded.
for inventory optimization. So I have seen some of the projects, they just implement only inventory optimization as a starting bed. Um, Once they get familiarized with the IBP, then they start migrating all the demand planning and supply planning, S&OP, and other control dot stuff. So I've seen that projects just simply run on kind of inventory optimization and then take it from there. So this is a simple supply chain network that I have built, and let me show you the master data also. So here, if you see, this is a location source master data. Remember, um, there's a ship from location, there is a destination location. These are the products. So here, if you see the plant one, it's called IO plant one, is ascending to IODC and sending a product called S13. IO plant 2 is sending to IODC, sending the same S13. So I think S13, to make the finished good S13, it requires two parts. One is a dual speakers, another is a motherboard. So these are the two components that goes inside the manufacturing process of the S13 finished good. So that, if you guys have remembered, that would be available in the production source header where we maintain the BOM structure for the finished good. And in the item, we maintain the item level details. So here you see the first row, plant 1 is manufacturing S13, and this is a BOM number. This is IO plant 1 underscore S13 underscore 0001 production version 1. So to make this source ID, to process this source ID, we need dual speakers, motherboards, and how many of dual speakers we need, how many components we need. One, that is maintained in the component coefficient. This we have covered in depth during our supply planning sessions. So the master data that we kind of required. So that's the master data. So this is a supply chain network. So there is a customer Amazon, there is a DC, there's a plan 101, plan 102, and there is a warehouse which is supplying the raw components. So, and also the finished good is S13, so it requires one motherboard, and then it requires dual speakers. So now what exactly the inventory optimization does? Inventory optimization, when you run that algorithm, just like the way when you run the supply planning algorithm, it gives a lot of outputs, right? Production plan, transportation plan, procurement plan, there are a lot of stuff, right? So what inventory optimization, it also gives a lot of outputs, everything related to the inventory. What exactly it tells is that if there is a demand of 1,000 for the customer Amazon for the product S13, and based on a lot of inputs, what optimizer says that how much of the inventory has to be maintained across your supply chain network. That's the thing, single line, the purpose of the inventory optimization. Across your supply chain network and across your products. So how much of the motherboards has to be maintained at plant 1? How much of the dual speakers has to be maintained at plant 102 and at warehouse? And how much of the finished goods has to be maintained at DC? Because motherboards and dual speakers components are not going to send to the DC. DC will have only finished goods. So why DC is having only finished good? Because that's how we have maintained our supply chain network in the location product master data. In the location product, we extend the products to the locations, and also in the location source, we maintain the transportation lane. So with that, the system would know that what location will have what product. And now the IO inventory optimization will tell that how much of the safety stocks has to be maintained at all the plants. Now, what are we going to do with the safety stocks? Let's say inventory optimization gave the output. It says that S13 DC should keep kind of 400. Plan should keep 100. Plan 2 should keep 150. Why, baby? Because the inventory holding cost is less in plan 102. So the costs also come into the picture here. What is inventory holding cost? The key figure that tells that the cost that the system would incur or the business would incur by keeping a unit of an inventory. So if the inventory holding cost is less for plant 102, system might say that okay, keep more stock. And will it always say keep more stock? No. There are a whole lot of other inputs based on that system gives this values. And the warehouse also, it says that okay, motherboards you keep maybe a 400, etc., etc. So now what are we going to do with this? We uh, so we can take these safety stocks and then we can feed into the supply planning algorithm, and when the supply planning algorithm runs, it considers these safety stocks and it comes up with the supply plan accordingly. Okay, so yeah, so that's where the inventory optimization logically fits in. If you are having your if you're having your demand planning, your supply planning, etc. So let me show you. So this is a high level thing. So first is a demand planning activity. We get the sales history, we do the data cleansing, we run the statistical forecasting algorithm, we verify the results, we do the adjustments and all that stuff. So finally we get the demand planning output, so that this is a demand. Okay, so logically we feed that into supply planning and then we run the supply planning, right? Or maybe run a forecast consumption and get the netted demand, take off the sales orders. This topic we have seen some time back, and we directly don't take the demand planning output. Then we do forecast consumption and then we run the supply planning. But between that also, we can actually run this inventory optimization and get our recommended safety stock. Let's see the flow. So demand planning, we get the DP output, demand planning output. So that we have to copy it into a key figure called as a demand forecast. This is a key figure that the inventory optimization reads when the algorithm is run. So this is the input key figure. So it takes the demand forecast and we need to run the algorithm. So obviously algorithm also reads a lot of other inputs, constraints, and then the model itself, the supply chain model, like which location has what products and what is the location source, what are the costs, holding costs, this and that, everything. So you can actually maintain all the data. I have excluded here. So but the main input is a demand forecast. You run your algorithm, you get the output called as a recommended safety stock. Now you can copy that recommended safety stock into another key figure called SOP safety stock. What is this SOP safety stock key figure? SOP safety stock key figure is sales and operations planning safety stock. So sales and operations planning. So this topic we're going to cover tomorrow. So SOP is a process like a weekly or a monthly process, sales and operations planning, where all the departments will come together and then they come up with one unified, agreed upon plan. So there they'll have a lot of discussions and then they will finalize that okay, this much of the stocks that we maintain. So so that so we copy the recommended safety stock into that, this key figure SOP safety stock. So that would be ultimately be sending. So there is a calculation for inventory target which reads this SOP safety stock. Remember the inventory target key figure? This is a supply input key figure. So we maintain the inventory target. The supply planning would respect the inventory target and will give you the supply plan accordingly. So this is a flow. As I told that in one of the project I have seen, they don't have anything in IBP. They started with IO. So they used to get all these inputs from APO system. All the demand planning output, they get it from APO interface, run the inventory optimization, send the safety stocks to the APO system again. So the APO will consider those safety stock targets and then it will run SNP and stuff. And along with that, They also bring other key figure data into IBP, and then reporting capability of IBP, all that fancy colorful things that IBP gives, all that alerts and stuff. So so yeah, so that's how the
Yeah, Venkat, just a second. So this
yeah, I can't hear
algorithm,
you, Amul.
yeah,
A
can you
lot of
hear me now?
disturbance.
Hello,
Yeah,
can you hear me?
yeah. Yes, yes, yes.
Yeah, yeah. So my question is on this inventory optimization algorithm. So does it
Mhm.
only consider the forecast, or I mean, it also looks at what master data setting I'm maintaining, what type safety stock I need to calculate, for the specific product locations. So how does it work?
Yes, it reads both master data and also it reads key figures, time series data, key figures. Key figures is a demand forecast, and it also reads the master data. So as I'm telling that first it reads like what is the bomb structure, what components are there, which location is having which product, and which location is sending which product to the destination location. So it reads all that. So if we don't maintain this, IO will fail. Not fail, IO will give you no results, because the master data is a mandatory one. So we have to maintain the master data. We have to. So coming back to this example, so we have to first declare the products S13 components and locations, location product. So DC will have S13, plant will have S13, motherboard, dual speakers. Warehouse will only have a motherboard and dual speakers, no finished good here. We map all of them to a subnetwork planning unit. Remember, a part of your supply chain network. And then we need to maintain the location sources, that which location is sending what product to destination location. Need to maintain customer source, what locations are sending to the customer entities. We need bomb structures, production source header, production source item, and all that. Yes, it reads the master data. And when you ask about how exactly it calculates safety stock, like in typical APO way, I think it's not doing it like that. This algorithm is a complete different, but it is still evolving. SAP is doing a lot of innovations in this. This inventory optimization is being acquired by SimpleOps, a company called SimpleOps. They have this patented algorithm. So SAP has taken it and then they have refabricated it, and then they made it to support this IBP key figures and master data and stuff. So,
Not
um,
part of
sorry,
no. So company you talk about is it simple
I
ops?
can't hear you, Amal. Can you?
Hello, can you hear me, Venkat?
Yes, yes. There's a lot of disturbance. I mean, I'm not sure whether it's me or this. Deepak is also getting the same issues. Yeah, whatever. Amal, yes,
Okay.
please go on.
Yeah, is it a smart ops or simple ops? The company you just mentioned.
Simple
The
ops.
algorithm.
Simple
Simple
ops.
ops.
So,
Okay. Okay.
SAP acquired it in 2014, I guess. So then once they acquired the Simple Ops, and then the entire thing started evolving. IBP started evolving completely. Otherwise, IBP was meant for just a sales and operations planning tool. So a tool, a web-based tool, where everyone can come and look for all the plans, all the finance plan, all the supply plan and stuff. But later on, they came up with this bright idea of replacing APO with IBP and stuff. But yeah, so this is the, it reads the master data, it reads the key figures, and it gives us the recommended safety stock. So so some theory on the inventory. Not sure whether you guys have. So I'll be, along with the supply planning, I'll also be sending the IBP 400 documentation. It's almost like some 400-page PDF. That is what SAP gives for the inventory optimization course, and then some other helpful documents, so you guys can go through it. So yeah, so there are three corners. There is a inventory, and then we need to have a flexibility in producing more or in sending more, etc. So we need to also maintain a right service. So the inventory is inventory waiting for the orders. We have more safety stock, the orders can be satisfied with that. And we need to have flexibility so that the assets that we have, the production assets, the logistic assets, can be optimally used. Then we have a service. the customer is waiting for the product. So what he's trying to say is that we need to have a right inventory. So if we have the right inventory, we can actually play in all these three KPIs, like the inventory and then the flexibility and then the service. But there's also a catch that when you have excess inventory, the working capital is at stake. So a lot of money is being tied up with your inventory. If you don't, expedite the inventory, your working capital is at a serious risk. And then for the flexibility, also you need capital investments to have the resources, to have the logistical resources and stuff. So and also to use them. Services, once you lose the customer sales, uh, you know things are at again high risk. So what is the solution for it? The solution is that you need to have a right inventory at all your nodes and for all products. So yeah, so inventory optimization helps manage uncertainty in the supply chain by determining the amount of safety stock to hold at the stocking locations within the supply chain. So in the master data, as I am telling, that for the IO, there are other stuff like stocking nodes. If you say S means it's a stocking node. If it is N means it is a non-stocking node. So that means we shouldn't keep any stock in that location. It just, the inventory has to just flow through that location. So it shouldn't keep any location. So that's why they've highlighted that we should keep it at the stocking locations. What does a safety stock do? Safety stock absorbs uncertainty, allowing you to maintain customer service levels. Inventory optimization determines the optimal safety stock for each stocking location and recommends the targets. So why it's important? Too much inventory, finance is not happy. Not enough inventory, customers are not happy. I mean, customer facing departments. So right inventory, wrong place, supply planners will be not happy. So what I mean to say is that in this example, you can keep all the finished goods at the plants itself. But what if the safety stock is not at DC? So you might lose up your sales because there has to be another transportation activity from plant to DC, and from DC it reaches to Amazon. So you need to have the right inventory, but also at the right place. And also like the components, let's say, so the component you're not supposed to keep it. I mean, let's say that um, the components has to be at the warehouse, so that the warehouse can send the motherboard and then the dual speakers to plant directly. So otherwise, instead of keeping the components at the plant itself. So that's the point here. It says the right inventory, the wrong place. So we need to have right inventory at the right place. So yeah, I mean, so there are some inputs. I'm just thinking, should we get into the system and then say it? Okay. Anyway, let's quickly say this. Let's talk about the inputs now. Demand forecast. This is the key input, kind of the important input, the major input that goes into the inventory optimization algorithm. The key figure name is demand forecast. The ID is technical ID is IO forecast. Input forecast for inventory optimization at the product, location, customer group, and weekly granularity. So input from the demand side for inventory optimization. Now there is another thing called as demand forecast error CV. So what was the error? The error CV for this particular demand. So it says that input forecast coefficient of variation for inventory optimization at this level. So let's see that. So let me get into the system. Let me bring that so that I'm opening the template. So the error CV is saying that how it could go wrong. So if the error CV is high, then system thinks that we cannot completely trust the forecast. So because it might have some errors. So see here, forecast error CV. So another important input. Along with the forecast, you also need to give the error CVs. So it has a lot of statistics into it. So yeah, we need more deeper look into this to especially to explain it to the business and stuff. So yeah, so if the forecast error CV increases, safety stock increases. Simple. Why? Because you're saying that your forecast is having a lot of errors. So it might go wrong or it might go right. So and then optimizer won't take any chances. So if the error is high, then system would say that okay, then let's do more safety stock. Let's keep more safety stock so that even if the demand goes wrong, so the demand is 1,000, but if you say the error is almost like zero point 0.9 or something, then it thinks that okay, even if the demand goes 2,000 or 2,500, then I have enough safety stock to cover it up. So, so yeah, so that's about it. So how forecast error is determined? So it compares historical forecast and sales data, calculating variability at the planning period length, granularity, and etc. So now the next question comes like, how can I know what is my forecast error CV for a particular? So here, so I already maintained. So I'm to go to the first tab. So there is a forecast of 1,000 here. So error CV I gave it as a point not 1. That means my forecast is solid. So that means very less probability of this going wrong. So this is 0.01. So how to make this thing? So th- there is another app in IBP which calculates all your forecast errors. So you could use that app and then you can get your forecast error CVs, or you can also maintain the error CV. So it's not a big deal, but we need the errors which says the confidence level of the forecast that we are having. So S13 product from the DC and the Amazon, the forecast is 10,000. Now forecast error is 0.001. There is a target service level. This is zero point 0.8. Target service level means that how much of the service that you want to give to this customer called Amazon. Like to put it plainly, if it is 8.8 is 80%, that means 80% of the times you want to meet the demand that Amazon is having. So but if Amazon is asking 1,000 units, so you should at least give 800 units to Amazon. So that's a service level that you want to maintain. So for important customers, you will have high target service level. For others, you can maintain a minimal one. So this is output, recommended safety stock. So now here you can see that it gave the output for all. So it said that for the product S13, at a DC, it needs to keep 123. The demand is 10,000. Forecast error is zero point 0.01. That's why it's saying that the DC should be 123 and then this thing. So let's go for another one. So let me show you. So let me create a scenario so that we can compare them side by side. Error CV, this is point not 2. This is another good functionality, like we can compare it side by side every time. So a scenario is created. Let's do some what if analysis. So you see column J, that is error is CV, error CV point not 2. Now let's maintain it as point not 2, saving the data. Now let me run inventory optimization on this particular scenario and see how the outputs would be impacted. The system might increase the safety stocks a bit up. Yeah, it is saved. It's a point not 2. Go to the run inventory optimization. There's something called as a global stage, multi-stage inventory optimization. I'm picking up this scenario, not the baseline. You see the first this thing here. It's called error CV point not 2. Version is a base version. Planning unit is IO, so they all belong to the planning unit called IO. So So there is something called the global multi-stage inventory optimization. That is, it considers your entire the entire supply chain network, and then it gives you the right this thing. Status inventory optimization. We can also run it from the front end. We have seen it, like how to create a template and how to schedule a job, etc. Interesting. It is taking a lot of time. Yeah, it shouldn't take that much time. Coming to the safety stocks, see now it has increased to 246. So it is saying that the DC should have 246, whereas the plant should have 45 and 45. But whereas coming to the motherboards, the raw materials, the plant 1 should have 70, the plant 2 should have 70, but whereas the warehouse should have a 437. Okay, okay. Now let's create another scenario and then increase the CV more. So let's go with the same name, error CV. Here I'll say it's almost like 0.6. That means high error. A new scenario will be created. It is error 6. Now for this scenario, we need to maintain the error for demand forecast is 0.6. Okay, saving it. Run inventory optimization. Error CV 0.6. Now let's pick up this scenario. Error CV 0.6. Base version. Global multi inventory optimization. IO planning unit. Next. Run. Okay. Also, let's bring both the scenarios so that we can compare them side by side. So for that, you need to bring another scenario. You need to edit the view. So let's go here to edit view. So scenario is the first one. Pick up both 0.2 and 0.6. So demand forecast is same 10,000 10,000 because we haven't changed that. Target service level is also same 0.8 0.8, but whereas error CV for the first scenario we maintain point not 2 and then next is 0.6. Let's see the status. It's finished. Okay, so there is a significant difference in. So let's come to the finished good. So in terms of 0.6 error, so you're saying 7,600 is your should be your recommended safety stock. You should keep safety stock of 7,600. Why it is so high? Because it's not just demand error CV, guys. I mean, there are other things also. Like you see, there is service level, there is a lead time, there is PBR, periods between replenishment, there are costs, there's a transportation cost, there are a lot of other stuff. That's why it came a very big number. But the point is this, that you change your error CV, you will see a different safety stocks. And the another important thing is that it is not just the finished good, but you'll see that it is also changing your raw materials. So you see the dual speakers raw material at warehouse, it has shot up to 18,000 from 437. So that's kind of a beauty here, that because it's considering the your entire supply chain network, because it's not just the finished good. So here if you say that this demand is kind of it is error prone, then while it is pushing it to your supply chain network onto your DC's plants and warehouse, it is also impacting your raw materials. So that's the thing with error CV. So now yeah, the demand error. So there is one is periods between review, that is the PBR, so you guys must be knowing it. So it is review frequency of replenishment specific to product location, not just location itself, because in that location for that particular product, what is the PBR? So in the DC, the finished good can have one PBR. In the plant, the same finished good can have another PBR. So this is a PBR. So the first one is error CV. If the error CV increases, safety stock increases. PBR, what does it mean? For a given item at a given location, so let's say S13 in DC, PBR is a frequency at which shipments of that item are received from upstream locations. So in other words, it's average order frequency. If for example, a PBR of 3 weeks means that on average, a replenishment order is placed and received for every 3 weeks. PBR cannot be null / fractional. So at DC, if you say it has a 3 weeks for finished good finished good S13, so DC it is coming from plants, and now it takes 3 weeks that the stock will reach out to the DC. So if the PBR is high, then obviously safety stock will also increase, right? Because it takes a lot of time for the finished good to reach your location. So if you increase your PBR, your safety stock increases. So yeah, I don't want to go and show you guys the example for it. You know it. Next is target service level. So customer service level input at product location customer group level. Um, so target customer, again, target customer service level. There's some math on it. But the point is that if you increase your target customer service levels, your safety stocks would increase. So let's do that also here. Let me go to the manage, and I'm deleting all my scenarios. So yeah, so to delete the scenarios, we have to first take out the scenarios from our planning view. Okay, now we came back to the normal with our point not 1 and 0.8 as our target service level. So now let me go and delete the scenarios. Click on delete and apply changes, and it's all done. There are no scenarios now. Now let's increase the service level. So keeping it here, target service level. So I'm saying TSL. Now TSL is I'm putting very low. So I'm just giving, or let's say 0.9 or maybe 0.1. That means this customer is not that important to you. So the target service level is way less. Now I'm picking up the target service level. Coming here, I'm saying it is 0.1. Save the data. Data gets saved onto this scenario. This is 0.1. Now I'll let's also create another one. So let's do it together. Creating a new one. It says, or let me run. It might confuse you guys. Running inventory optimization. Picking up the scenario called target service level 0.1, not the baseline. Planning unit is IO. Next. So you see that the S13 at DC, it is saying that you should keep only 44 as a safety stock. And the raw materials also, dual speakers at plant, it should be 13 units. So that's it. So it has brought down the safety stocks significantly low because your target service level is very, very less. So you might not want to meet the customer demands that accurately. So, but now if I increase my target service level, it's a 1. So this is 1. Now running this new scenario, target service level 1. Let me bring both the scenarios side by side so that we'll see the results for both the scenarios. So we have that both the scenarios here. The demand forecast for point 1 target service level is 10,000. For 1 also it is 10,000. So everything is same. The RRCVs are same, but whereas target service level, they are changing. For TSL point 1, it is point 1. TSL 1, for scenario TSL 1, we have target service level 1. Now if I go to the output safety stocks, so at the DC, for point 1 service level, it is 44. But target service level 1, it became to 407, so almost like 10 times. And then not just the finished good at a DC level, the customer facing node, but also the finished good at plants, the finished good at plant 2, the raw materials at plants, raw material at warehouse. So we can see the impact of it. So I created a very small network. So that's why you might think that, okay, this is just a small this thing, but imagine if you have a real supply chain network and you have everything in your system, and so the impact is like very, very high. You have a demand at a finished good, and you have these target service levels and stuff. So how that will impact your entire supply chain network and your inventory positions across your network, and also inventories for your components, your semi-finished goods, and your finished goods, etc. It's kind of a pretty powerful tool. So, and like what else we have? So we have lot sizes. You can maintain the lot sizes in here. Lot sizes also will impact the IO, and then there are supply related shifts. So this is all like demand, but now supply here is a lead time, the P lead time, the production lead time, T lead time, transportation lead time. So if the lead times are high, then obviously you can expect the safety stocks to kind of increase. And then the lead time variability. So what if your lead times are they are prone to error? So you think that it takes 2 weeks, but it might change. It might change here and there. Then again, you can maintain the variability, and again, IO will respect them and gives the safety stocks accordingly. So we have the ratios and other things. So we've seen PBR, we have seen error CV, have seen the target service level. There are lead times. There's a lead time error. There are lot sizes. So I think in case of lot sizes, if the lot size increases, your safety stock decreases, and the lot sizes are maintained in the in the master data as an attributes. So remember we did some time back the production lot size and the transportation lot size, minimum and maximum, and the rounding values also. Then we have the inventory holding cost rates. So if the inventory holding is high, safety stock decreases. And also not just that, but also system has the intelligence to pick up the right location so that it can keep the demand. So that means what I'm saying is, let's say if the plant has a higher holding cost for the components, then system might say that keep all the costs in warehouse, you know, or something like that. Let's see that. So let me go to the view here. See, they always trying to auto adjust. So let's do one thing. So go to edit view here, sheet options. Um, okay, so I think I need to maybe save the template. Then, so there is this button called auto fit column width. So if you select it, the system would do auto fit, but if you don't select it, then it will follow your thing, like whatever you adjust for the column, it will take that. So if once I save the template, then it would be fixed onto this column width. So now let's go to the costs here. So this is the inventory holding cost. So now let me make it as 0.2 and 0.8. Just give some decent values, error of 0.2 and target service level as 0.8. So now coming to the costs here. So let's go to the components called dual speakers and motherboards. Which location? In the plants. So here what I'll do is here, I'll so here I'll say at the warehouse the costs are high. So at the warehouse the costs are high, but whereas in plant it is just $10, $10, and plant two also just $10, $10. Now let me create this scenario. I'll give a name called inventory holding cost, IHC. Um, Higher IHC at the warehouse. Okay, higher IHC at the red warehouse. So warehouse is having $100. $100 for every unit of the motherboard, for every unit of the dual speakers to keep in that warehouse location. Now if I go to the now let's see how that would impact our safety stocks. Oh, I clicked on S&OP operator, not this. Inventory optimization, global multi-stage, IO, higher IHC at the red warehouse. Everything is cool. Next, run. Refresh. So now here you can see that system has done nothing at warehouse. So it has kept a 0 at warehouse, but whereas in plant 1 and plant 2 it maintained 1044 for dual speakers. Motherboard also it kept at plant 1 plant 2, and finished good of 461 and 461 in here. So yeah, so it has chosen not to keep any of this thing. So but if I increase my my error CV and then my target service level, then we might actually expect some safety stocks also to be at a warehouse location. But as everything is under control, everything is kind of as per the ideal situation, then system said that let's not keep anything at warehouse, let's keep everything in the plant itself. Okay, now let me create another scenario and then I'll reverse this. So let's go to cost here. I'll create a new scenario. Now IHC, what is the name? Higher IHC, I think. Yeah, higher IHC inventory holding cost at the plants. For components, so now here I'll maintain a bit high, so I'll say here uh, uh, at the plants, right? So I'll say 70 and then 70 $70, just giving a random value. So here I'll just say for 10 and 10. So now the warehouse is will not incur that much cost. So yeah, we're good. So let me run. Okay, I should also bring both the scenarios so that we can compare it. Hmm. So here, in case of this scenario, when the warehouse is having the come on, when the warehouse is having the highest cost, then plant has more stock to keep. But whereas when the plant is having very high cost, then system said keep only 120 of the dual speakers, but whereas the warehouse should keep 843. So that warehouse will send 843 whenever the plant requires the production of the finished good. So I hope you guys are following. Um, mm, but yeah, it's like this is how the costs would impact your inventory optimization algorithm also. So there are other things like maximum inventory that you can keep at a location, whether the location itself can have a stocking node type, and etc etc. So yeah, so I think the documentation would definitely help. So so yeah, anything. Demand forecast, error CV, PBR, target service level, lot sizes, lead time error CV. So I haven't maintained any lead time. So because I want the results to be very simple, everything I maintained on the first bucket, that is current bucket. So you see here, I just maintained only on week 33 so that we can effectively compare the results. So that's why there is no lead time. So I haven't maintained any lead time. If I bring the lead time, then yes, then I have the ratios here. So all these scenarios that how it would impact. So yeah, and when you actually try with running the inventory optimization, you should know that demand stream master data is a mandatory one. But whereas with the supply planning, there is no demand stream that we need to maintain. But whereas with the IO, hey, 1 second, guys, just give me a minute break. 1 second. Just go through this meanwhile. Hey, sorry guys. Yeah, I hope you guys are there. So demand stream master data is a mandatory one. What is demand stream master data? So there's something called as a source. So the name is demand stream. It's called it's like customer source only, but instead of customer ID, we have a customer group. So that's the only difference. So we have to maintain this master data, not the customer source. Like instead of maintaining the data from a customer ID level, you can actually do an aggregation and then create a group, and then you can maintain the target service level is for the group, so not for the individual customer ID. So here in our example, I just have only Amazon, so the customer ID is Amazon, the group itself is Amazon, so I just maintain Amazon as a customer group. Like sometimes you guys know it, right? Like I mean, the Reliance will have Reliance North India, Reliance South India, Reliance this, Reliance that. But for Samsung, in the customer hierarchy, so they might just call them as Reliance Group. That's it. Reliance Digital. That's it. So and now for the whatever the demand is there for Reliance across, so I'm just giving an example. The example could be wrong, but yeah. So you need to maintain for a customer group, give the Amazon, and if it is just only one customer ID that belongs to customer group, even then it's fine. You just maintain that, but you need to maintain this in here. So here actually you see this 0.55 is for the target service level. Target service level is an attribute as a key figure. So now let me edit this. So here if I change it to 0.999, save it. Now I think you remember we talked about attribute as a key figure. So we maintain a static value in the master data, so that would be copied across the horizon for the key figures. So now if I come here, if I go to the input, so okay, it is rounding off. It is rounding off and showing 1, but it is 0.99 here. You see it's 0.99, 0.99 across the horizon. It would go till the end. So okay, not till the end. Interesting. So it is going till only so till week 43 of 2019. Why it is going only till week 43 of 2019? Because that's how the settings have been maintained. So let me show it to you. So model configuration, go to the planning areas. Okay. Uh, Not sure, guys, whether we talked about it. There is a new app for the planning area. Like the configuration, we're doing it in the in the old way, right? So that there is a new app also. Let me show the stuff in there. So our planning area is test conf 2. So test conf 2, test configuration 2, test configuration 2. This is the time profile, status is active, blah blah blah. Let me open this. So here it has 532 key figures, 109 planning levels, 3 versions. See on to the right hand side, it's gone. So now it is showing all the elements inside this planning area, attributes, planning levels, attribute as key figures. Now if I click on this, so it is showing all the attributes as key figure. You remember we have created few for our this thing. So where is this? See this maintenance job duration, long back we have created this. So this, I think this stands for inside the location, for every resource, whatever maintenance job is happening, the duration we are maintaining it here. And here we said it is 0 to 52. That means if I say 10 hours is a maintenance job activity, so that 10 hours would be copied from current bucket till the next 52 buckets, that is 52 weeks, that is 1 year. So this is where the from period and to period comes in. So where was our target service level? Let me control F, target. Yeah, this is our target service level. See, source customer group is a master data. Let me click on this. It will directly take me to that master data. This is interesting feature, right? Yeah, click on that. This is called source cust group. The name is demand stream. So here the key is customer group. Then you can click on this, it will show you the attribute details. So the ID is cust group, the name is this, data type is varchar, length is 60. So this is kind of an interesting feature, like you can explore from here to kind of everywhere. So yeah, now let me go back. So click on this back, it will take you to the page here. So attribute as key figures. Here is target service level. Yeah, so here you can see the target service level is from 0 to 12. That means from current week to the next 12 weeks only. So so that's why it is copying 0.99 from current bucket to the next 12 buckets. So yeah, that's with the master data called demand stream, and the variable and the attribute called as target service level. So the value would be coming from the attribute as a key figure, but you can very well go and change it and save it, and then you can run it. So not a big deal. So you remember last time when we initially opened, you can see all 0.55555 across, but here I maintained it to different service levels, and then we ran the scenarios also, right? So that means the target service level key figure is an editable key figure. Again, that depends upon the configuration. So if you say that this is not an editable, then there is no other way than to come here and maintain some value and save it. And the only way to tweak this key figure is to tweak the attribute as a key figure itself. In the configuration, if you make it as editable, then you can very well go and change it, and then you can play with it. Okay, that's the thing. So demand stream is a mandatory one, you have to maintain that. PBR and inventory holding cost rates must exist for all product locations, for all the components, for all the finished goods and semi-finished good across your locations. So PBR, it could be inventory holding, it could be like, some value has to be there. So some inventory holding cost has to be there. Target service level has to be there for all the finished goods. Obviously, target service level is for the finished goods and for the customer group. T lead time must exist for products that have transportation source defined. I think this is not mandatory because I don't have any transportation lead time, and also I don't have a production lead time. I think this is not mandatory, but these are the mandatory ones. So you have to have all the stuff. Okay. So yeah, that's about inventory optimization, guys, and I'll share you the IBP 400 document. One second. I think you guys have already have it. Some of you have already have it.
Yeah, but Venkat,
Sure. Yes.
yeah, we got all the books, I guess. This, this, I don't know, I mean, Angie or I forgot his name actually. They already forwarded to us. The thing
Hmm.
is, what if you were preparing or some other documents, that you were supposed to share. I don't know, I mean, whether you have shared with those guys, but
No, no,
you
no,
haven't.
not yet.
No, no, not yet. Okay, okay. Because we haven't received anything
Yeah,
yet.
Amol, not
About
yet.
that.
Yeah.
Yes, I agree. I know that they haven't reached you guys. I am kind of piling up whatever I have. A lot of echo coming in, guys. So yeah, apart from this 400 and stuff, this is a 223 page document. This is supposed to happen for 2 days, blah blah blah. It talks about everything. It talks about attribute. It sometimes they even go like what is attribute and stuff like what is business planning, and analyzing key figures and planning levels, examining attributes and mass data types, everything. It talks from the scratch till it goes. So yeah, so apart from this, I'll also share the documentation, and that yes, I mean that's kind of a standard thing that we do. Like once the course is done, we'll also share all the documentation, like whatever has been shared with you guys. So all the like all these every day we are dealing with some PPTs, right? All these PPTs also will come in apart from the other documentation that we have. And also tomorrow show you guys some important links where you can get more information about IVP and all the stuff. Yeah. Okay, then let's catch up tomorrow. Tomorrow would be the sales and operations planning class. Okay. Um, then we'll continue there. Okay. Thanks, guys.
Okay, well, yeah.
Sure. Bye.